Hello, Algebra 2 students. Today we're looking at 4.8 remainder and factor theorem, plus we're looking at those rational roots. So review here that remainder theorem, synthetic substitution. Remember, after dividing a polynomial by that linear divisor, that remainder will be some constant. So we have this example here where it's asking us to plug in -1, -3, +5 into this equation over here. So what we're going to do is we're just going to use synthetic substitution to help us find that remainder. So here we have -1, and we're plugging it in for 1, -5, -7, 29, 30. And once again, we're dropping down that first term. That's -1, -6, +6, -1. That's a +1, that's a +30, that's a -30, gets me my remainder of 0. So that's P of -1. We're plugging in another term here. We're going to plug in -3, do the same thing, 1, -5, -7, 29, 30. Drag down the 1, that's -3, that's -8, +24, +17, that's -51. Yeah, and then add that down, that is a -22. It's +66, which makes that 96 as we get as a remainder. And then one last one here, plugging in 5 and using those same terms, -7, 29, 30. Hard to see over there, but we get 1, 5, we get a 0. 0 there makes that -7, makes this -35, makes this -6, gets me -30, gets me another remainder of 0. So this is going to help us on the next part down below. Basically, that next part down below says, hey, where is this graph going to cross the x-axis? Well, it's when we get these remainders of 0 here, which we'll come back to here in a split second. So this next part here says factor theorem. The binomial x minus a is a factor if and only if that remainder is 0. So which of those values above had those remainders of 0? That's what we talked about. We found those two. The question is how could we find those remaining factors? And that's what we're going to talk about just after this page. We have this thing called the rational root theorem. Basically, it says if the polynomial p of x has integer coefficients, then every rational root of the polynomial equation p of x equals 0 can be written in the form of plus or minus q. And that was tough to read because that's not the right color that I wanted. Plus or minus p over q, where p is a factor of that constant term, q is a factor of that leading coefficient. So we're going to have to look at those two values, come up with our p, come up with our q, look at those plus or minus p's over our q's to find possible roots. And normally on any test or quiz, we're going to give you a graph that looks like this, what I call a bad graph, where maybe not every single point's listed, but we give you enough information to draw a few good conclusions. So here on this first example, remember that p is that factor of our constant term. Our constant term here is 30. Q is our leading coefficient, it is 2. So once again, we're looking at all of our factors of p. So 30 is 1 and 30, and also 2 and 15, and 3 and 10, and I ran out of room, but I also have 5 and 6. Q is 1 and 2. Those are our two numbers that multiply to 2. So when looking at each of these possible ones, I should get 1 over 1, 2 over 1, 3 over 1, 5 over 1, I'll do 6 over 1, 10 over 1, 15 over 1, 30 over 1. So when I divide those all by 1, I'm going to get plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, plus or minus 6, plus or minus 10, plus or minus 15, plus or minus 30. But now I have to divide all of these numbers by 2, so I should get 1/2. I should get 2 over 2, which is 1, so I already have that one. 3 over 2 is plus or minus 3/2, plus or minus 5/2. I have 10 over 5, which is 2. I need 15 over 2. and I have 30 over 2 and 6 over 2 already. Those reduced to the numbers that we have up above. So those are all our possible roots. So I don't want to test. So when on that first problem, I tested all of those 3. To be fair, I could test all sorts of points. I could test from negative infinity to infinity to see where our graph is going to cross the x-axis. But now I'm limited myself. I'm down to about, I think that's 24 different options. So positive 1, negative 1, positive 2, negative 2, positive 3, negative 3. All of those are different options for us. But here they kind of give us a graph of a rough one. So it looks like it crosses right there at 5. So I'm going to try 5. So our goal is to see, once again, I'm trying to find these 4 zeros and where they're exactly at. So I'm going to try 5 and do synthetic division here to help me. 5930 when I'm writing this out. So I drop down the 2, that's 10, that's negative 1, multiply is negative 5, that's negative 13, that's negative 65, which is negative 6. Hey, look at that, I got my remainder of 30. My bad graph kind of worked out. So my goal is to find the other 2. Well, if that's 5, maybe 1's here, 2's here, 3's here. 3 is one of my possible roots. It's not going to be 4 since it's not up there. So I'm going to try 3 for my next one. And once again, I'm going to use this reduced polynomial here, or some people call it a depressed polynomial. 2 times 3 is 6. That makes me 5. This is 15, which gets me 2, which gets me a positive 6, which gets me another remainder of 0. So now here I'm almost out of room. But I can factor this polynomial here. It's really 2x squared plus 5x plus 2. So once again, I'm going to multiply this 2 times this 2 is 4. Multiplies to get 5 is 4 and 1. Remember that is that middle term split up. So it's 4x and 1x. I'm going to put my plus signs here and plus 2 and do my factor by grouping. So I'm going to take out a 2x, I'm left with x plus 2. I'm going to take out a 1, I'm left with x plus 2. So my final factored answer here is 2x plus 1, x plus 2. Once again, these are my zeros, 5 and 3, but I also have to set these equal to 0. So I'm going to skip some steps. When I do that, I should get negative 1/2 and negative 2. That's kind of tough to read there, but that is a negative 2. So those are my 4 zeros. I found where they cross the axis at each of those. I know that took a little bit of a time, but we only got one more problem to go through to look at that. So we got one more problem here. We're looking at 9x to the 4th minus 33x cubed plus 22x squared plus 20x minus 8. So once again, they gave us a graph. Want to make sure that we get our p's over q's, so we limit the number of possible ones we could get. Once again, our p-value here is 8, q-value is 9. That is our leading coefficient in our constant term. Our p-value here is 8, which gives me 1, 2, 4, and 8. Those are my numbers that multiply to get 8. 9 is 1, 3, 9. So when I'm looking at all of these numbers that are possible combinations, we get 1 over 1, which is 1, 2 over 1, 4 over 1, 8 over 1. But I also have to do this over 3, so I get plus or minus 1/3, 2/3, 4/3, and even 9/3. But I also have to do this all over 9 as well. That should have been 8/3. There we go. Which is 1/9, 2/9, 4/9, and 8/9. Once again, we're probably not going to use the fraction ones. We're probably going to try and get all of the ones that are possible, all of our whole number ones first. Those are the easier ones to plug in. So here I'm going to plug in 2 here. I think 2 might work. So if I plug in 2, I get 9, negative 33, 22, 20, negative 8. Drop that down, that's 9, that's 18. That's negative 15, negative 30, that's negative 8, negative 16, that's positive 4. Hey, look at that, I got my remainder of 0. but I see at this point, it's not exactly going through that point. It's actually bouncing at that point, which is that multiplicity of 2. So let's try 2 one more time with my compressed function here. And hopefully I get another remainder of 0. 9 times 2 is 18, that's 3. 3 times 2 is 6. Negative 2, that's negative 4. Hey, look at that. Got another remainder of 0. The goal here now is to help factor this. So once again, this is 9x squared plus 3x minus 2. We look for numbers that multiply to negative 18 that add to get to 3. That is 6 and negative 3. So once again, we split that middle term up, 9x squared plus 6x minus 3x minus 2. We do factor by grouping. I can take out a 3x out of the front, leaves me with 3x plus 2, take out a negative 1 in the back, that's 3x plus 2. Once again, our final grouping here, 3x minus 1, 3x plus 2. When I solve, I should get that x is 1/3, x is negative 2/3 to get my 4 answers. So those are 2 answers, those are my 2 answers, which get me my whole x to the 4th, which is my fundamental theorem of algebra, that my degrees and my number of roots are the same. If you have any questions, you can always contact me or reach out. But thanks.